Good day everyone. In this video, we will discuss about the ideal gas law. So what is ideal gas law? The ideal gas law is a fundamental equation in chemistry that explains the relationship between the pressure, volume, temperature, and number of moles of a gas. It provides a simplified model of how gases behave under various conditions. The ideal gas law explains how gases behave. It shows the connection between pressure or how hard the gas pushes, volume, the space it takes, temperature or how hot it is, and the amount of gas.
Ideal gas law is expressed in an equation PV is equals to nRT, where P represents the pressure of the gas, V for volume of the gas, N for number of moles of gas, R for ideal gas constant, and T for temperature. For further explanation of the used terms, first is the pressure of the gas or P. This is the force exerted by the gas molecules when they collide with the walls of the container. For an ideal gas, pressure is inversely proportional to volume and directly proportional to temperature. Second, volume of the gas or the V. This refers to the space occupied by the gas. As pressure increases, volume decreases, and as temperature increases, volume also increases. Third, the number of moles of gas or the N. This is a measure of the amount of gas present in the system. The number of moles is related to the mass of the gas and its molecular weight. Fourth, ideal gas constant or the R. The value of R depends on the units of pressure and volume. The gas constant allows the equation to balance its units, ensuring consistent result. Fifth is temperature of gas or T. This must always be measured in Kelvin in the ideal gas law. Kelvin is an absolute temperature scale where 0 is absolute zero.
K assumption. No intermolecular forces. Gas molecules do not interact with each other. Negligible volume. Gas molecules themselves occupy no volume. Do in reality. They do, but the assumption simplifies calculations. Understanding each variable. Pressure. The force exerted by gas molecules on the walls of their container. It's usually measured in atmosphere or pascals.
Next is V or volume. This refers to the amount of three-dimensional space that the gas occupies. It is typically measured in liters. For gases, volume is often the volume of the container, since gases expand to fill their container. The next variable is T or temperature. It represents the absolute temperature of the gas. It is a measure of the average kinetic energy of the gas particles. The higher the temperature, the faster the particles move. Also, the variable T or temperature must always be measured in Kelvin when using the ideal gas law, because the Kelvin scale starts at absolute zero where molecular motion ceases.
Understanding each variable. The moles is defined as the amount of gas present expressed in the terms of the number of particles, which can be atoms or molecules. The mole is a standard unit used to count a specific number of particles. Application of the ideal gas law. Understanding gas behavior. It helps explain how gases expand, compress, and respond to the changes in temperature and pressure. The ideal gas law demonstrates the relationship between pressure, volume, temperature, and amount of substance for an ideal gas. Ideal gas is a hypothetical gas that perfectly fits all the assumptions of the kinetic molecular theory. The ideal gas assumes that all gases behave perfectly and identically to the rules of the kinetic molecular theory.
The ideal gas law provides a reliable approximation for understanding gas behavior. However, it's important to note its limitations. Real gases deviate from the law under extreme conditions, such as very high pressures or very low temperatures. These deviations occur because the ideal gas law assumes no interactions between gas molecules and negligible molecular volume, which isn't always the case in real-world scenarios. Despite these limitations, the ideal gas law remains highly useful, particularly for calculating unknown variables. By knowing any three of the four variables, pressure, volume, temperature, or moles, you can easily determine the fourth. This versatility makes the law invaluable in both scientific and industrial applications such as gas storage, engine design, and chemical reaction analysis.
The ideal gas law is a fundamental principle in chemistry that describes the relationship between pressure, volume, temperature, and the number of moles of a gas. Understanding this relationship allows for accurate predictions of how gases behave under varying conditions, providing valuable insight into their dynamic properties and responses to environmental changes. In essence, the ideal gas law serves as a powerful predictive tool for comprehending gaseous behavior. And that concludes our report on the ideal gas laws. Thank you for your time and consideration.